Okay, let's do some homework. Slope intercept form is what we started today, so let's check a couple of these questions so we can make sure we can answer them correctly. So you said slope intercept form looks like y equals mx plus b, okay, where y is just the letter y, m is the slope, x is just the letter x, and b represents y-intercepts. Which is good to know for all the questions to do. So first couple just say, if I can switch this around. Okay. So find slope, find the y-intercept. So slope, oh my god, squeaky door. Slope's the number right next to x. So in this case, well, I don't want to do number 1. We already did number 1 again. Let's skip down. Let's do number 5. So number being multiplied by x is 8. So we say m is just 8. Okay. And then our y-intercept is this number at the end. So number at the end is this minus 5. So we say b is negative 5. And that's it. That's all we got to do. So pick the numbers out of the equation. The only time it gets more complicated, even a little bit, is when it doesn't look just like this. So number 6 says y equals x. Just technically still in this form, even though we don't see these numbers. We just have to remember what we know about basic rules of how numbers function. So something times x equals just x. So we need to know what is this number we can put in front of x when there's no actual number. The only thing you can multiply x by that won't change the value is 1. So we can rewrite this as y equals 1x. Okay. And then we need something at the end here. So what can I add to x that also won't change the value? So we know we can always add the number 0. So y equals x has the exact same value as y equals 1 times x plus 0. And once you can see it like this, we see our slope and intercept. So our slope is 1, and our intercept is plus 0. We don't have to put the plus, it's positive or neutral, so we just call it 0. That's it. So that's all we have to do for the top 6 is just find slope and find intercept. So really the challenging questions were really just 7 and 8. 9 is kind of straightforward. It goes back to this rule here. So I wanted to look at number 7 to make sure that we can go from a table to an equation to a graph. So number 8 is the same thing. It's just it gives you the equation, so it's write a graph. So let's practice that. So 7 says, in this problem, you'll investigate graphs. Okay. So math club, planning a trip to the amusement park. Okay, so we want to plan the trip to the amusement park. And shows bus prices and admission price. So we want to compare the price for both these places, Wild Waves and Coaster Havens, depending on how many kids we take. Okay, so we're going to write an equation to represent total cost. So each of these equations, we can say this is Wild Waves. Every equation we write is in slope-intercept form, so it's going to look like this: y equals mx plus b. Actually, we can move this down here so it won't go away. So we're going to start with y equals. Now m, slope means rate of change. So if we have bus fee and admission price per student, which of those represents a rate of change? Well, we see this word per student. That's for each student. So this is what changes depending on the number of kids. So this gets to be our slope. This is going to be m. So we can say y equals 16.5 times, remember x is just a letter, we're just going to call it x, okay, plus, and then our y-intercept is our initial value. It's where it starts. It's how much it would cost if we didn't bring any kids. So we look, what are we being charged even if no kids show up? And that's this fee here. Okay, so we'd say that's our y-intercept. So equation will look like plus 200. Now we can do the same thing for our second place. Coaster Haven. Still going to start with y equals. Only now instead of 1650, their cost is only 1450 per kid. So times x. Remember, y and x, just letters, don't change. You just put them in. Plus, and their fee is 250. Okay, so there's our two equations. Now we just have to graph them. So to go from equation to graph, because we're still new at this and it doesn't hurt to practice, we've been making tables here. So we'll start with wild waves. So x is our kids, and y is our, it tells us here, is our cost. Cat is terrible. Okay. So if we start, the fewest number of kids we can bring is 0 kids. So we're going to start with x as being 0. So that would be this animal's running wild. What are we doing? Here's our equation. So 1650. We're going to replace x with 0 plus 200. 1650 times nothing is nothing, plus 200 is 200. So for our first place, 0 kids go, cost $200. Okay. Now the next smallest number we could use is 5. Right? But I have decimals here. I don't want to multiply decimals by 5 because that's just going to give me more decimals. So I'm going to skip ahead. I'm going to say how much is 10 kids. So if you did 5, that's fine. That's fine. You'll get the same line. I just don't want to work that hard. So 1650 times 10 plus 200. The reason why we do times 10 is anytime you multiply by 10, it just moves our decimal one place over. So 16.5 times 10 is just 165. Plus 200 is 365. Okay. And then we can keep going. We can say 20 kids. So 1650 times 20 plus 200. So this is just twice as much. So if we double 165, that would be 330. If you don't believe me, you can work that out by hand. Or you can grab a calculator. But that's correct. Okay. And then this would be 330 plus 200 is 530. Okay. And one more. And in this case, we can also say each time, this is going up by 165. So our last one should go up by another 165. So if you don't want to do this part, you could say what's 530 plus 165 more, and then it's a little bit simpler, but you have to gotta make sure this one's correct. So if we add this, that gives us 695 kids, or dollars. So 30 kids cost $695. Now this is enough to give us a good line. So let's plot some points. So 10, 365, between 300 and 400. 20, a little bit more than 500. And then 30, a little bit less than 700. And then we just connect our points. Almost perfect. Okay, so we're halfway done. I know, grumble, grumble. So we go to our second place now. It's Coaster Haven. Okay. Make another table. X can stay the same. 0, 10, 20, 30. Okay. But this equation, a little bit different. Instead of 16.5, it's 14.5. We replace x with whatever x is. So again, we start with 0. plus, and their fee was $250. So 14.5 times 0 is still nothing, plus 250 is 250. So this line, our y-intercept, is a little bit higher because they had a bigger fee, so that makes sense. And then our next one would be 14.5 times 10 plus 250. So 14.5 times 10, same thing as up here. We just move the decimal over one place, so that's 145 plus 250. So that is 395, right? Okay, our next one, 14.5 times 20. So again, this would just be twice as much as what we had here because we doubled our kids. Instead of 140, this would be 290 plus 250. And if you're confused, why do we keep adding 250? It's because no matter how many kids we bring, we still have to add these $250. And each time we set the equation up again, we're thinking of a completely different situation. So we're not repeatedly adding 250. We're adding 250 one time for each situation we consider. So let's see, 290 plus 250 is 540. And then again, same as last time, we can look at it. Instead of having to write the equation each time, we can look for the pattern. So this is increasing by 145 each time. So our last one would go up by 145. So 145 plus 540 is 685. Okay. So hopefully this works out all right. Let's plot our points. So 10, 395, so a little bit less than 400. 20, 540. So just a little bit more. And then 3685 is actually going to be a little bit less. One of these points isn't right. 10, 395, 540. These should be like right on top of each other. That's how close they are. So let's connect them. Let's see what this looks like. Change it to green. Ugh. This is not the best situation. Usually they give you these and the point where they cross is much more obvious. Let's see, so for how many students are both of these trips the same? So let's look. So looking at here, it's right around 20, right? But we know that they were, if we look at 20 on both of these, it was $530 for one place and $540 for the other. So we can say, let's do this a couple ways. Let's say if we want to keep this simple, we can say somewhere around 20 kids. Okay. Let's say that's not good enough, or your lines look better than mine because you have better art skills, and you don't have to make such big dots because you're not recording this. What's the exact answer? So let's see. The difference in cost here is $10. Right now, this place is $10 more expensive. Okay. Now let's compare that to how many kids they're bringing. And the difference in cost, the difference between $16.50 and $14.50, we subtract those, is $2. Right? So this place is $2 cheaper for each extra kid we bring. So at $2 each, how many kids would it take to make up the difference? So 10 divided by 2 is 5. So 5 more kids than 20. So this should actually be 25 kids. That's a much better answer, and you can kind of see that here. Because again, my line's not great, and the scale's not that great. And if we had not counted by tens, I guess we could have counted by fives and gotten that as well, but that's okay. Right? Right. What am I? Yeah, that works. Okay. Happy with that. Let's see. So now we can answer these questions. If 20 kids decided to take the trip, which trip will cost less? Oh, we were just looking at that. So at 20 kids, right, our first place was less expensive. So at 20 kids, Wild Waves would be the least expensive, less expensive. And then it said, what about 28 kids? So at 28 kids. So we said the break-even point, where their costs were exactly the same, was 25 kids. So as soon as we bring more than 25 kids, Wild Wave stops being the correct choice. Right? So if we have 28, that's more than 25. So the cheaper option would be our Coaster Haven. And that right there, it's a basic idea. Won't take you as long to do the next one, hopefully, because you won't have to explain everything to yourselves. This is it. If it gives you an equation, make yourself a table. If you don't know what to pick for x, follow the graph. The graph will be labeled. You can use those numbers to help you. Okay? And then you can either do the math, you can find the pattern, and that pattern is based off of the slope multiplied by however much x is going up by. Okay? However you want to do it. So you're going to graph two more lines. Now I'm talking about number 8 when I'm explaining this. You're going to graph 2 lines, and then you're going to compare those two. Okay? And if it says which one costs less, and our y-axis is measuring cost, the higher the line is, the more expensive. So if you want the cheaper value at any specific x value, you want the line that's lower at that time. So give it a try, see what you can do, bring it back tomorrow. All right, good night.